Hello guys, in this video we are going to know about the Pascal's law. What's the Pascal's law? Yeah, have you ever thought about the forces? I mean, how the a big car lifting up, even by applying small force. Like here we see. Here we are applying small force. By small force we are lifting big car, which having the weight of some 2 tons, maybe 3 tons, maybe. Uh, yeah, 3 tons maybe. Like, but here we are not applying the 3 tons of force to uh, to lift this car, but we are applying even less than that. But how can this force, small force, can lift this big car? Here is the solution. That is nothing but that is a Pascal's law. He found that one thing. What he found here, pressure is transmitted through the fluid. Is whatever it may be. He doesn't say about the whether maybe I mean nature of the fluid, but he said of the only law. But he, according to him, nature of the fluid is not decided, but it should be incompressible. Like it should not decrease its volume. We know incompressible, its volume should not be decreased. So then what it is we call incompressible. One the condition is that incompressible, it can transmit the pressure equally throughout the liquid, so that we can lift the car with small force. Okay, here we go. Here we see here for input force and output force. Like output force is upwards. Like a here we have car. How the small force is balancing the big force. That is like here we see this is the Pascal's law. Pascal's law states that a fluid is rest in a container like this YouTube shape, but here area of cross section is different, and a pressure change in one part is transmitted. Like here pressure changed. Initially there is no pressure, like at the pressure on the surface is equal to the atmospheric pressure, that is like 1 atm. Yeah, is now we are applying some force. Why we are applying force? To lift the car. So when there is a change in pressure, it is transmitted throughout the fluid without loss any portion. So here the pressure is equal to here the pressure in the container. So here we observe here A2, here A1. This area is so much less than when compared. Yeah, here we go. Here this area is bigger than compared to this, but for pressure transmitted here, like a pressure applying here. So pressure at here and pressure at same height should be equal according to the this Pascal's law. What he said, it is transmitted through the fluid to any portion. Okay, when we neglect the height, so pressure is transmitted every portion of the fluid and to the walls of the container. So here pressure should be equal. So F1 by A1. Why no? Pressure is equal to force by area, force per unit area. Okay, but it is different from the stress. It is all about the internal things, but is pressure about the external things. Yeah, pressure can consider also internally, but stress means it should not be external. It comes under only when you discuss about the internal things. Okay, here F1 should be is equal to F2 by A2. You know, F2 is so much greater and A2 is so much greater. And what is the F1 should we apply to lift this? Yeah, let me erase it one. Yeah, here we go. Yeah, so F1 is equal to A1 by A2 and F2 is the weight of the car. And when you compare A1 by A2 ratio, like this one to this one, okay, then A1 by A2 is is less than 1 when compared. When a1 a2 compared, a2 is bigger, so a1 by a2 is less than 1. Yeah. So f1 is less than f2. So when applying small force, we can bear a big force. That's the output. I mean, what is the conclusion and observation of the Pascal's law? It is very important. We can use in physical systems. Okay. Have a nice day. Thank you, guys.